Good morning, class. And this is a recorded video of some sample problems that I hope you can uh, solve on your own, and it's very easy to follow. So this is a simple stress and strain problem. The problem is a metal wire is 2.5 mm in diameter and 2 meters long. A force of 12 Newton is applied to it and it stretches to 0.3 mm. Assume the material is elastic. Determine the following. So, aside from assuming that the material is elastic, we'll also assume that the metal wire is not hollow. So, if you have a metal wire and its diameter is 2.5 mm and its length is L is equal to 2 meters and it stretches to 0.3. When you applied a force of, so maybe the force is 12 newtons going there and 12 newtons going there. Okay, nasabdan na class. So, the first, we will find the stress in the wire. So, before anything else, what is the formula of stress? Diba, your stress is equals to your F and A. So, what is the first thing you need to do is, you have to know what are given. So, given are the diameter, 2.5 mm, the length, that is 2 meters, and the change in length is 0.3 meters, and of course you have an applied force of 12 Newton. So in the formula of stress is equals to F force over A. Your A here is the area that is being stressed out, or that is experiencing the force, and this is the force applied. So in this diameter, unsa man ang area ang nagkuan sa stress as a force, di ba kani? So what is the area of formula of the area of a circle? Assuming that it is not hollow ha, dili ni siya hollow. So formula is pi d squared over 4. So to find the stress, we have to first find the area, and our area is pi 2.5 squared over 4, and we have our area equal to 4 point, get your calculator please and follow with me, squared 4.909 mm squared. So now we can find our stress experienced by the wire. So the stress is equals to 12 over 4.909 is equals to, so you have Newton per mm squared, or that is equal to 2.44 Newton per mm squared, where this is equal to 2.44 MPa. So this is the first question. The second question is to find the strain. So the strain is basically change in L over L, and that is equal to 0.3 mm over L is 2 meters, and that is equal to 2000 mm. Point 0.000015. So that's it. Okay, our second problem is finding the modulus of elasticity, and this is if you will read it at first glance, you will makita mo nga lisod siya, pero when you try to solve it, dili di ay, because almost everything is given, di ba? All you have to do is to plug all the given to solve your problem. Ang importante, nakabalo ka kung unsa nga formula ang gamiton. So, basically, dapat memorize din yung formula. If not memorized, familiarize the formula and the units involved para dali ang ato ang mas dali po mo makasolve ang mga problems. Okay? So, our problem is, a steel tensile test specimen has a cross-sectional area of 100 mm squared and a gauge length of 50 mm. The gradient of an elastic section is 410 times 10 raised to the third power Newton per mm. Determine the modulus of elasticity. So, before anything else, we have to be reminded of the formula of elasticity. So, elasticity is stress over strain. Diba? Stress over strain. That is your elasticity. And what is given? So, given is your area, which is 100 mm squared. Given is your length, that is 50 mm. And gradient. So, unsa din ang gradient? Gradient is, when you define gradient, is basically F over delta L. Right, delta L. So, this is gradient. It's a ratio of force over the change in length. So, and we will find E. So, our solution is we have to play around with the known data. So, you have your E, and you have this is your formula of modulus of elasticity. So, we all know that your stress is equals to F over A, and your epsilon, or your strain, is equal to delta L over L. So, therefore, your E, F over A over delta L over L. So, this is equal to F over delta L times L over A. And familiar, this is given because this is the gradient. Okay? And therefore, E now is equal to, this is given, and the value of this is this one, 410 times raised to the third power Newton per mm times this one. Your L is 50 meter, I mean 50 mm, and your area is 100 mm squared. So that is equal to, get your calculator. Sorry for my handwriting. I hope maklaro pa siya. 410 times divided by 100. So that is equal to, so can cancel it, right? So that is equal to 205,000 Newton per mm squared. Or that is simply equal to 205 gigapascal. Okay, our third problem is your assignment. So your assignment states that when a force P here is applied in a rigid arm ABC, A, B, point C, point B displaces vertically downward through a distance of 0.2 mm. Determine the normal strain developed in wire CD. So we will find the displacement or the strain that is CD. So this is since the force applied is downward, automatically, basically our strain here will be also in this direction. So by simple trigonometry, if this is your point A, this is your point B, and before you apply P, this is your point B, and after you apply P, your B prime will be here. So basically, sorry, tagpo. So nasya dire. This is 400 mm and this is what? 0.2 mm. So we are asked to find the displacement at point C. So basically that is the strain experienced by the wire CD. So if this is your A and this is your B, this is your C. Before the applied load P, this is your D. After it was applied, if this is your B, this is your C. C prime and B prime. So this is 0.2 and this is, we will assume that it is X. Okay? So by trigonometry, the ratio and proportion, it's basically as simple as this. And this X is equal to your strain CD. Okay? So, the given, what is given? The given is, okay, the given are the length AB, length AC. AB is 400. AC is, length AC is 600, of course, for kani. B is equal to 0.2 mm. So, ratio and proportion again. Since we have this and we have that, you have displacement at B over LAB is equals to displacement at C. This is our given, and we will find CD. Okay, so our solution is here. By ratio and proportion, we have 600, and this is 0.2 over 400. So displacement C is equal to times 600 divided by 400, 0.3 mm. 0.3 mm. So this X is equal to 0.3 mm. Therefore, our strain at point CD, so basically, muna siya atong displacement at C, or in the previous example, we call this delta C over the length at CD, right? So this and we already know it's 0.3 mm over this length CD, because it is connected, diba? So kung nibaba ni siya dire og 0.3 mm, automatically kani siya kani nga string, kani nga wire, if you call this wire, musta ka puri siya, ma-stretch ni siya into 0.3 mm. So muna siya ang iyahang change. So from 300 mm plus 0.3 mm, after the application of load P, it experiences, the total length, the new length now is 300.3 mm. Right? So, muna na siya. So, divided by 300, .001 mm per meter, and that is your strain developed in wire CD.